I hope you guys are interested in energy, and I'm sure you are, because energy affects everyone, right? And whenever you turn on a light or do anything, you can think about, or don't think about, where does the energy come from? And you've probably heard a lot about the energy crisis, how we're trying to figure out how we can get enough power to everybody, not only generate it, but also distribute it. So there's a lot of challenges in that. So I'm going to tell you a little bit about why we need to find alternative energy sources. What are some creative ideas? I know you're here today to learn about being an entrepreneur. So as you're listening to this talk, start thinking, well, how could I invent something to solve that problem? Or look at some of the proposed ideas and see how you could make it better or come up with something different. So I'm going to talk to you a little bit about what NASA's involved with, but also it's a little broader. The talk has a few other organizations, what they do. Just feel free to think out of the box and be prepared with some questions at the end if you need to. We're going to have 5 minutes to go over that. So I'm just going to start right in, and I'll start giving you some ideas after each thing. I'm going to have to stand over here because we got to put the page down here. So now, what are humanity's top 10 challenges? There was actually a guy about a few years back. He's a Nobel Prize winner, and he said, I need to take a look at what are the top 10 challenges for humanity in the next 50 years. You can see in the red the top 10 things. We have energy, water, food, environment, and then of course poverty, terrorism, disease, education, democracy, and population. And those 5 red highlighted things are things that NASA is also working on to explore space and to learn about new science. So you can see how the big challenge is, right? In 2004, we had 6.5 billion people on Earth. In 2050, we'll have 10 billion people. So it's almost double the number of people. And so it's gonna, you can probably tell things are getting a little more crowded around here, and all over the world, it's even getting worse. So we gotta give energy to all those folks. They need it for day-to-day work and healthy living, to make sure their food refrigerated, all the types of things that we use energy for all of our daily tasks. So what are some things that NASA can do to help? How many are aware of the latest Mars Rover landing? Did you guys watch that or see stuff about that? That was pretty awesome. You know that Mars Rover on the bottom there? That's actually a picture of that the rover took of itself on Mars. It's the Curiosity lander, and it turned its own camera around and took a picture of itself sitting there on Mars. So how very cool is that? And so you can see on the top one, that was a cartoon picture of the previous 2 rovers. There's Spirit and Opportunity, and Spirit and Opportunity landed about 8 years ago now, I think. But now we've got this new and improved rover it's about the size of a Volkswagen Bug. So it's a very large rover. It's amazing. They were able to safely land that on Mars. But how does this have to do with energy? Well, the interesting thing is those 2 Mars rovers, the Spirit and Opportunity, were powered by solar panels and a battery system. So during the day, the solar panels would gather that weak sunlight on Mars, because it's that much farther from the sun, right? And it would store up energy in the batteries, and then overnight it would have to kind of rest because it didn't have enough power to do much. But then the sun would come out, and then it could do more. Well, you know what? This new rover is a nuclear-powered rover, and it has a nuclear isotope system that, in this picture, if you could see it, there's like fins sticking up. Well, the folks at NASA Glenn helped to design and build that thing. So now it can run all night. It can run day and night. It can just keep going and going because it doesn't need the solar energy to run. So how cool is that? So there's even in everything we do for NASA missions, we have to think about how to power things. And so we're coming up with newer ways to make energy systems for not only Mars and also all of our missions, but we can apply them to our terrestrial work. So, whoop, I gotta do the next one here. Now, what about wind power? Turns out years ago in the 70s, when we had an energy crisis in the 70s, we decided at NASA that we should take some of our technology and figure out how to make a really powerful wind turbine that could convert wind to electricity. And so we came up with these giant megawatt-size wind turbines. And so now you start seeing them all over the place. How many have actually seen one of these large wind turbines? Have you seen one? There's one parked out in front of the Science Center in downtown Cleveland. That's probably the most easiest to find. It's sitting right next to the stadium down there. Well, actually, that's a spin-off of NASA work years ago where we invented those large wind blades, and we've got it all working really well, and now companies are building and selling them, and we're putting them into use. Well, where could we use them here in the Ohio area? This is a study that somebody did. It was the Cuyahoga County set a study out to go and figure out where would we put wind turbines. And if you can tell, the darkest blue, which is 10 meters per second average wind speed, is out in the middle of the lake. And so you say, well, okay, that's interesting. What good is that? You know, how can we use that? And so people are looking at perhaps putting some of these wind turbines out in the lake. You see this big line of wind turbines. We'd have to put them where they don't interfere with boat traffic and everything. But that might be a way of having getting our wind, the most use of our wind resources. There's also some other designs that people are starting to look at. The top one is a single-bladed wind turbine. Taking a look at, well, maybe that way you only have to make one blade. Maybe that's less expensive, right? You know, half the number of blades or a third the number of blades. So that's one thing to look at. How do you do the gears and the turbine itself? There's a lot of things to study and make better in the wind turbine. And then another idea is to put rooftop wind turbines. So you see on the bottom here, there's a small company out in California that's building these devices. They're about 4 feet by 4 feet, and they put them on the edge of a building, because you know when wind comes and hits the edge of your building, it has to come up over it, and as it comes up over it, it accelerates, and so that fast moving air can be caught into this wind turbine and make power. So that's one of the things they're looking at. So how about solar power? Does anybody know somebody with a solar-powered home? Anybody has any on their home yet? Not yet. There's a few people that are going out there and actually putting them, because Ohio's not that bad of a place to have these. So there's a lot of technology that people are working at to try to get these to be used in our homes. There's probably a lot of you that have those little solar-powered lamps that you put in your front yard to light up things at night. But pretty soon we'll be able to do more and more with that. Well, did you know that the amount of solar energy hitting the Earth is 165,000 terawatts coming down every day? And when you say, well, how much is that? That sounds like a lot, but I don't know how that measured up against anything. Well, it's 15,000 times more than what the whole world uses every day. So there's a lot of energy coming right to our doorstep. So how can we use it? We have to look at a way to gather that sunlight and turn it into electricity and make it useful and distribute it. One of the concepts that folks are looking at is, what about, because the drawback on the Earth is that the Earth turns and it becomes night, and then there's your solar power's done, right? So somebody said, well, what if we went up into space and went away from the shadow of the Earth, and we put a big solar collector up there, and then we can beam down to Earth, even at night, we could beam down the solar energy. Maybe we would convert it into laser light or maybe microwave beam, and then we'd beam it down to a big dish antenna on the ground where we could collect that energy and then distribute it in wires, maybe make a power system like that. So this is just like a concept. There's a lot of things you can question about, well, how would that work and why would it be less expensive, and all those kind of things. But it's kind of a neat concept that you can think of how you could make it applicable to something on Earth, right? Another thing is that once you get this power right now, typically you take your sunlight and you convert it into its DC power that comes out of or direct current, right? Comes out of a solar panel. Well, you can't just like hook that up to your wires and just plug something into it when everybody has AC appliances right now. unless you own an RV where you got a lot of DC appliances, right? Well, you need to have a solar panel, and then you get an inverter, because the inverter has electronics in it, can take that DC power, make it AC. And then you can hook it up and make what we call grid-tied solar systems. And so we actually have a demonstration of this at NASA. We had a big field, as you see in the lower right, big field of leftover solar arrays, because at NASA we invented and put together the space station's solar panels, those great big solar panels the size of a football field that are in space right now powering a space station. We built that system and we got it set up at NASA and tested the original solar panels. So we said, well, hey, while they're sitting here, let's hook them up and let's power our buildings with it, right? So this is something we hooked up, and now we're actually making power for our buildings with these solar panels. And there's a lot more power needed, of course, but at least it cuts down the power bill, right? Another thing that we've done is research on solar cells. So you can make more and more efficient solar cells. Your little ones that you have in your lights in the garden are maybe 12 to 15% efficient, and the space ones are 30 to 35% efficient. And so we're trying to make even maybe more efficient than that. The theoretical limit is 60% efficient. So that means the amount of sunlight comes in that gets converted to electricity is more and more of that sunlight is getting used and not wasted. And so one of the guys that used to work in our photovoltaic research area retired, and then he got thinking about what if we concentrated the sun's energy onto a little thin area and made the sun really, really strong in one area. Can we put a super solar cell there to suck in all that energy at that point instead of waiting for it to be, like distributed over large areas? So now we need less solar cells. So he came up with this device. You can see the big collectors are kind of focusing the sun up to that crossbar, and the crossbar has these special solar cells in them that have to be actually water cooled because it gets so hot. Like 900 suns worth of energy is focused down onto that, so it gets so hot they have to cool it with water. But they actually have a field of these they're starting to build in, I think it's in Mentor, is the very first power system being built of a whole field of these types of devices. So there's an idea that somebody actually went, and we may be seeing more of these in our future. Now, what about wave energy? We've got the oceans, they're always just churning and churning and churning, making waves. You go, well, how could you take that wave energy and turn it into electricity? So it's kinetic energy, right? Kinetic energy is anything that's moving up and down or just moving, like just walking. Have you seen, I'm sure that some of the kids' shoes where they walk and as they're stomping down, you can see the lights coming on in their heels. That's converting their kinetic energy into the electrical impulse with piezoelectric systems. Well, there's these guys got this idea, well, there's all sorts of ways to convert the kinetic energy into electrical. And you see the young man there, Aaron Lemieux, he's actually a local guy, lives in Cleveland, Ohio, and he invented a personal power system. It's a small, maybe about this big, maybe a little longer, device you throw in your knapsack, or you can wear it on your belt. And as you walk, it's shaking up and down, and your kinetic energy is getting turned into electricity to power up your cell phone or your laptop or whatever you want to power it with. So you can look up online. Tremont Electric is his company. You can see more about what his latest devices are. But let me show you another thing. Here's how we'll get back to the wave energy in the ocean. What about if you had this big floating cylinder, the big yellow thing on the outside you see, and inside you have a coil of electric coil that's mounted to this cylinder, and then you have a big magnetic shaft down the middle. Have you ever done the experiment where if you take a magnet and you run it through a coil of wire? Have you ever gotten the electricity coming out of the coil of wire? That you can do that quick experiment. Just wrap a little wire around there and run a magnet through it and put a voltmeter on the ends of the things. Well, you'll be making electricity. So they said, well, what if we put the big barrel out there floating, and then we tie the magnetic shaft to a big cable that's bolted on the bottom of the ocean. And then every time the wave comes by, the outside moves up and down and up and down, and then it then moves, the coil stays moving up and down on that shaft, that magnetic shaft, and it's making electricity as it's bouncing around out there. And then they said, well, now we just got to figure out how to get a big extension cord out to this thing, but that's easy. We can do that. We know how to do extension cords. Well, guess what? That cartoon figure, I've been showing that for about 5 years now. Well, guess what? In October, they're going to put this thing out in just off the coast of Oregon. They're just about to go and put this out there and get it working. So they got a company, actually started building these things in New Jersey. It's a New Jersey company, but the northwest part of the U.S. has some serious waves that just don't quit. I mean, they're just going and going and going, right? So those, they said, well, that'd be the ideal spot to put these. But they're most worried about winter, when the real big storms come in and the huge waves. They're the most worried about those. But so if it can make it through this winter, once they put it in October, we'll see how it goes. They're looking at, they have funding already to put 10 of these generators, which would power about 1,000 homes. So this is coming true. So some of these cartoon concepts, they actually are building these. And here's another cartoon concept, but maybe I'll have a picture in a couple years of them actually doing this. What if you had like we'll call it an underwater wind turbine, right? So they're tidal stream turbines. Have you ever seen, I think it's if you go to Disney World, they have, and I don't know, maybe it's old, but they have a Bay of Fundy, I think. Have you ever seen that? That they have the highest tides and the lowest tides, where they show the boats sinking down onto the ground, and then they come back in, and one tide goes up and down about 20 feet. So what if you put these turbines in a place where the tides are always going, or where there's a current, like out in the Gulf Stream, where it's just constantly going and going? So you could put these underwater, and they could use the water currents to make the electricity, just like the wind turbines are doing. And the concept of them, like say you need to fix them, right? You wouldn't want to have to go down there all the time and work in scuba gear. They had this concept that it could just pop up to the surface, and you could go and fix them from your boat and then pop them back down. So this is another kind of a cool concept that maybe we'll see in use. Now, for those of you that like either chemistry or physics or combustion or just inventing materials, this is a cool thing that I just found out about on the web about a month ago. The folks at the Department of Energy have this supercomputer, and the supercomputer, they're making designer materials, they call them, where they actually take, they invent these new materials that are theoretically possible to make by saying, okay, what if we combine this and that, and we'll make a polymer material that can filter out carbon dioxide. Because you know that carbon dioxide is one of the worst greenhouse gases that's committing all this, contributing to global warming. And so if we have all our power plants spewing out carbon dioxide, if we could somehow collect the carbon dioxide easily and stash it away, pump it up, put it into containers, and use it for maybe supplying to people that need carbon dioxide in their industrial processes, reuse it, do something more than just let it float around in the air. So they invented, at least on paper and through the supercomputer, a type of polymer that they could make as a membrane, and then they can pass the exhaust of all of our power plants through this, and very efficiently, and they're saying 100 times more permeable to carbon dioxide than any of the other materials they've gotten up so far. So we're looking, this is very, very new concept, and this is how you start. You start with an idea, then you got to work it through to make a real product, and then you got to make it through to where it actually gets demonstrated and sold and people buy it. So this is at the very, very beginning of an idea. What about another energy source? Liquid fuels, right? If you all see, you go up to your pump and it says contains up to 10% ethanol. We're taking corn and we're turning it into a biofuel and mixing it with our gasoline to try to extend our amount of our gasoline. But there's probably a lot better ways to make that oil or to get that oil for that purpose. And so here's a list of crops you could grow and how much oil is yielded in gallons per acre of land that you use to make these biofuel crops, right? So corn, it takes it'll make 18 gallons per acre. So you get a whole acre of land and you just get 18 gallons of fuel out of that, or oil. Well, now cotton, here's some more, soybean, blah, blah, blah. But when you go down to algae, look at that. You could, if you have a big, like a growth pond where you're growing algae, you could get actually 1,200 gallons out of an acre of land. And then if you have a different type, like if you can mix it and do something more efficient with that algae pond, you got a potential of 10,000 gallons per acre. So there's a lot of algae research going on. Department of Energy's funding it. A lot of work's being done to how do we practically make this algae and turn it into fuel. So that's the chart that gives you hope. Wow, that could be a big improvement. But then here's a concept that one of the guys at NASA Ames came up with. How about if we grew our algae floating on the sea and put it into big plastic tubes because when the sun's beating down on your algae, if you just took laid it out on the ground and you had real hot sun on it, it's going to kill the algae. It gets too hot. So you kind of need to cool it. So he said, well, why don't I just take this bed and lay it on the ocean, and then nobody's really using that ocean surface anyways. The ocean's really big, so you're not using land, and you're actually using the ocean water to cool your algae pond. So he says, what if we made a whole bunch of these, like just laid them out on the ocean, had them all hooked up, and then, by the way, that's where a good place is for wind turbines, right? So we put those out there. So this is a kind of the futuristic, it's a refinery, it's a place to grow the original oil itself. And you can see back there in the corner, that's the refinery making the actual gasoline that you could come and get. And then the wind energy powers the whole thing, and any extra power could go to ship it to up to the shore to power your buildings, right? Well, how can we have another problem. It's called transportation, right? So transportation, do you think our future highways are going to start to look like this? I mean, you keep seeing people adding more and more lanes to our highway. Can you imagine being that poor guy in the what is that, that's like 8 or 9 lanes over here, and you got to make the next exit? It probably takes them, 10 miles to get moved over to get off the exit. So anyway, that's just getting crazy, right? And look at all this pollution in that city. That's really getting bad. So here's one of the options that we're thinking, that we're going to open up a hydrogen fueling station that actually makes hydrogen right there using water. We hook water to this electrolysis system, and electrolysis, did you ever take a little battery and you put the wires and stick them in water and you watch the little bubbles come off of that? If you haven't done that, it's safe. Go ahead and do that. Just put wires, stick the battery, and take the wires in the water. And that electricity is breaking the water into hydrogen and oxygen. And so the hydrogen is the fuel. So we're taking hydrogen, putting it into this fuel cell powered bus, and a fuel cell uses the hydrogen, and the air is providing oxygen. And so it's kind of running backwards, like we just talked about electrolysis. Well, a fuel cell takes the hydrogen, the oxygen, and then turns that into electricity, and just water just drips out the back end. Oh, 5 minutes. So this is a nice fuel that we're looking forward to using, because it doesn't have all those smog and the mess that's you can see from the previous picture. It's also way more fuel efficient, and you just have water you make it right where you're at. So we don't have to ship things from overseas. We don't have a lot of oil spills and all that. There's a lot of advantages to this. It's very clean, very quiet. It's electric bus basically, powered by this fuel cell. So we're looking forward to having one of those in Cleveland. So over the fall, you guys come ride on one. The RTA will be driving it around through Cleveland very soon. There's another guy that had this idea. What if I had a personal vehicle that was like a monorail, and it was all electric powered? So this company called Skytran Technology has built a concept vehicle. See these little pods that hold about 4 people or so? you can walk up the stairs, get in one, and then it goes up onto that high-speed rail and zooms you on home. And so then they have to get, you know, like where do all these go and how does it might be like the replacement for a subway or something like that, but it's all electric powered and you can put it right where people have to walk and go down to their stores and things. So these guys are right on the edge of making this a product out in California. So in conclusion, you know, I mentioned our biggest challenge is to produce energy for 10 to the 10th people. And in order to have world peace and prosperity, we need it to be cheap. We can't be fighting each other over energy sources, right? And so we can't do this with just our current technology. We need, you know, young folks like you guys to start thinking about how can we solve these problems. And you need to really, the people that study physical science and engineering are the ones that are going to be able to solve this problem for us. And so just like after Sputnik, where everybody got worried that we don't want to be left behind in the technology area, we got to, you know, get psyched up and get back into studying science. And so be a scientist and save the world. We need a bold new Apollo program, just like where we got psyched up when we went to the moon. Well, here's Neil Armstrong, and kind of we remember him this year. He passed away, unfortunately. His words to us were, I think we're going to the moon because it's in the nature of human beings to face challenges. It's by the nature of this deep and inner soul. We're required to do these things just like salmon swim upstream. So we can't just let this energy crisis beat us, right? We got to, you know, get busy and do our thing. And how are we going to put all these lights on, and it's going to be more and more lights and more power needed. So it's up to you folks to solve our energy price problems of the future. So thank you very much.